Morgan Lyons, KI5SXY, aka Rocket Girl, is a fifth-year undergraduate student pursuing a BS degree in aerospace engineering at University of Missouri, the Missouri University of Science and Technology. I'm so used to calling it Rolla.
Yeah, UMR.
Yep. S&T. She intends to obtain her MS in system engineering beginning in January of 2025. Morgan launched her first rocket in March of 2021 and instantly fell in love with the hobby. And she has a whole bunch of credentials about that, but I think she'll tell us about it. So,
Yay! My turn.
please.
Okey-dokey. Are the mic levels good? Can you hear me all right?
I'll wait till you start talking.
Oh, okay. Well, let's get this thing going. Yay!
Yeah, dim the light.
Where's the... There we go. Yay, it works. I usually like to move around, but I guess I'm tied to the podium. So, hi everyone. Good to see y'all. Glad y'all are here. This is a lot of people, more than I was anticipating, but happy to see everyone. I recognize some faces and see a bunch of new ones, so good to meet you all. So, my name is Morgan Lyons. I am Kilo India 5 Sierra X-Ray Yankee. No, it's not a vanity. I got lucky. Only girl in the club at the time when I got my license, so here I am. I am an aerospace engineering student at Rolla, S&T, Missouri School of Mines, whatever you want to call it. I am graduating this December, fingers crossed, as long as I don't fail my art class and my senior capstone project. I will be starting my master's at S&T in systems engineering in January, and then who knows what's going to happen after that. Not me. I've been a ham for quite a while. I'm coming up on 3 years of being a ham, so definitely not as long as some of the folks in the room here, but I know I bring the age down by about 20 years any ham radio room I'm in. I am an extra class operator. I got my extra less than a year after getting my technician, which I'm very proud of because I don't know anything about electrical engineering. And I'm also the president of Whiskey Zero Echo Echo Echo, oldest club on campus at S&T. We've been around for 101 years as of this October. Very proud of that. I like to talk. I like to rag chew, if you haven't figured that out yet. And I love contesting. I'm actually going on a de-expedition next month. I am being sponsored by the the Rich Handel Young Lady Operator Travel Fund, to go to PJ2T in Curacao. So if you are doing CQ Worldwide, listen for me on the air, PJ2/KI5SXY all that week. Love 40 meters, that's my favorite. And I'm a level 3 Rocketeer. I think that's what y'all all came to hear about. It's cool. Y'all know about ham radio, so I figured I'd talk about rockets. I am a part of the Tripoli Rocketry Association, which is one of 2 major clubs in the United States. There's the Tripoli Rocketry Association, TRA, and then there's the National Association of Rocketry, NAR. My personal high score is 11,000 feet with this beauty right here, Malice Bene. She is my pride and joy. 11,000 feet, supersonic, 9.5 feet tall, 5 inches in diameter. Y'all can get a closer look after the presentation. I just ask that you don't touch them, please. They're not breakable or anything, but they make really loud noises if you drop them. I've also worked on team rockets that have gone to 30,000 feet and more than supersonic. So this one, it was like Mach 1.01, but that's enough for me. The others were like Mach 2. So yeah, a little bit about my club, just a shameless promo because I'm very proud of my club. I made that logo up there, the MST ARC one. That one's pretty neat. Like I said, we're founded in fall of 1923. We do a lot of contesting. Last year in sweeps, we think we got second. I don't know if scores have come out, I haven't been paying attention. But we think we got a clean sweep as well, which is quite cool. And then Last year we got third in the school club roundup, second if you count the teams that were competing with legal power. We go to Hamvention, or have been going to Hamvention for the last couple of years. I spoke at Hamvention this last year, this last go round for the ARRL's Collegiate Amateur Radio program, so that was a lot of fun. We are involved in that and sponsored by the league in that regard. And we've got a pretty good club going on right now. We've got probably 15 active members, and you can see us in that picture down on the bottom right hand, or yeah, your right, my left, and our gorgeous tower. We've got a couple of beams up there. It used to rotate, but then it broke, so we're waiting on a grant. So if you want to donate to our club, we're always looking for money. As far as I'm aware, it's pointing southeast, which isn't the worst direction in the world, but it's not the best. I like to DX a lot, so you can only get so far when you're pointing towards the Gulf of Mexico. But yeah, we do a lot of cool things. We will be sending out spooky memes in October on SSTV, so be on the lookout for our SSTV memes. And yeah, oh, I forgot to mention, I've been the president for 2 years. This is my 4th semester being the president of the club, and I will be done. Like some people in this room, after this semester, I will be done being the president.
Is that because of graduation?
I'm graduating, I'm becoming a grad student, and I want to shove it off onto someone else. I don't want to do it anymore. So yeah, amateur rocketry. Y'all can read that. It's basically launching rockets that aren't for commercial use or government use. It's just a hobby. It's for funsies. And all of these are considered amateur rockets. I am not a professional just yet. They haven't given me my piece of paper, so I am an amateur still. So there are a bunch of things you can do with amateur rocketry. There are different classifications. There is low power. The classifications are determined by the motor. So these are low power motors right here. This is an A class motor as in Alpha. This is a C as in Charlie class motor. These are low power. Anyone can launch them. You can buy them at Hobby Lobby or Walmart. And you use them with little rockets like this one right here, or this one right here, my little tiny one. Those are considered low class.
Well,
Oh well.
that didn't make a big noise. Do it again.
It's hit the ground harder than that. But yeah, these are like Estes rockets. That's what most people know them as, Estes rockets. You launch them as Boy Scouts or when you're young. And you just shoot them up, and sometimes they explode, sometimes they come back down. Depends on how good you are at assembling them. A through O are commercially available. O is an Oscar. Mid-power is, you don't need a license for either. That goes up through G class motor, as in golf. And then once you get to H and up, you do need a license. So H and I are level 1, which is this rocket right here, the little one, about 2,000 feet apogee. And then level 2, HI, JK, and L are level 2, which is this red and black one, about 4,000 feet up. And then anything after L, MNO, P, Q, R, S, depending on how big you go. Is for this big rocket right here. This one I actually used an M motor. It's this size. So I think y'all can see a pretty good difference between the size of the motors. So a question I get asked a lot is, what kind of fuel do you use? These actually are the same kind of fuel, more or less. You can have different colors, different efficiencies and stuff, but these are the same, and it's also the same as the solid rocket boosters on the space shuttle. So the 2 white rockets on the side of the big orange rocket, same stuff, just smaller. But yeah, this is M as in Mike. This is what I use to launch the big black and white one.
Are they reusable?
They are reusable. Well, sometimes. You can get disposable motors like these. They're just like little cardboard tubes, like little coin roll tubes filled with propellant. Once you burn through it, you just throw it in the trash. Or you can do a reusable motor, which you buy. It's a little bit cheaper, but you have to have the case, which is a little bit more expensive. But this aluminum case just goes, you fill it with propellant, it goes inside the rocket, you launch it, take the spent propellant out, reuse the case, clean it out, stuff like that.
And is that off the shelf?
Yes, that is commercial off the shelf.
What's the igniter?
The igniter is like this, actually. So, and I'll answer questions if y'all don't mind holding them to the end, please. It's okay. So this is kind of like the igniter. This is an E-match, electric match. It's a bad resistor. It blows up whenever you put a current through it, and it'll ignite the rocket. The ones for igniting that big motor are a little bit bigger than this one, but it's got a little phosphorus head on the tip, and use it to ignite the motor and ignite the pyro charges, which I'll get to in a second. Student competitions are a big deal in college and for some folks in high school. Project Lead the Way type thing, maybe. I don't know, I'm not from Missouri. Spaceport America Cup is a big one that is out at Richard Branson's Spaceport America, the Virgin Galactic Spaceport. There's also the Argonia Cup, which is one of my personal favorites. That's out in Argonia, Kansas, which is in the southern central part of Kansas. That is the Cloudbusters organization. Spaceport is the Experimental Student Rocketry Association. And then the Student Launch Challenge, which is done by NASA down in Huntsville, Alabama. And then you can also get a little funky with it. You can do space shots, which get really, really cool. That big, tall plume right here, that's actually the first successful civilian space shot ever. It was done in 2004 by my friend's dad, Kai Michelson. He's a really cool guy, by the way. It was called Go Fast. It was by the Civilian Space Exploration Team in 2004. I was alive then, I just want to make that clear. I was around in 2004, I'm not that young. The first time it was done by students was in 2019 by the University of Southern California Rocket Propulsion Labs. It's called Traveler 4 because they did it on their 4th try. The other 3 blew up or didn't come back. But if you can imagine, October sky type era, it's been around since the 50s. Long, long time. Took 50 or so years to get a civilian rocket to space. And mind you, it's only going up only 100 kilometers or so, 300,000 feet above ground level. That's called the Kármán line. It's considered the edge of space. So it's not going into orbit or anything. It just goes up, kisses space, and then falls back down ever so gently. So here's some things that I've worked on. I've worked on something like 11 rockets over the last 2 or so years that I've been doing rocketry, or 3, 4, however many years. So this big one right here, this yellow one, that one I designed the paint job and helped build. That was called Killer Queen Remastered. The first Killer Queen did not end well, so we remastered it and made a new one. There she is actually launching without her paint. She had to earn her paint. But that one only went around 13,000 feet, but it weighed 130 pounds and used an O motor. O is an Oscar. The gorgeous sunset looking one, that one's called Dioscuri, which is another name for Gemini, the twins in mythology. And so that was for the Argonia Cup rocket. The goal of that was to send a golf ball as a payload up to 9,000 feet and then have it land in a controlled manner. So we actually teamed up with the drone team at my university. They built a drone that folded up. It looked kind of like an octopus, so they called it Kraken. And it carried the golf ball and up inside the rocket. Then once it got to a controlled altitude, we ejected it. The arms popped out using springs, and it glided down to the target just behind the flight line. And we actually got second place the second year I went. That rocket we didn't place because it landed about a mile away and the drone didn't deploy. But the second time I went, we got second place. We were about 2 inches off by first place. First place was 10 inches off the center of the target, and we were 12. But it was a good competition. Then there's my level 3, Malus Bene. She's gorgeous. Like I said, 11,000 feet, Mach 1-ish. But yeah, I designed, built, and launched all by myself. That's part of getting the certification, is you have to do everything by yourself. I did have advisors in the rocketry club that helped me out and made sure I wasn't going to kill myself doing this. So they kind of watched over me and were like, yeah, you're doing good, or maybe try it this way. But it's a completely original design, and I manufactured almost all of it. I bought the tubes and the nose cone, but put it all together, designed the paint job, assembled it, did a lot of drilling and epoxying and fin layups. So here is kind of the basic outline of what happens in a model rocket. Usually they are dual deploy, which means you have 2 parachutes. So the rocket sits on the pad, you arm the electronics in a dual deploy. You have to have onboard electronics that look kind of like this. They go in a tube coupler halfway up the rocket, about right here. There's some knobs, switches actually, that I use a screwdriver to turn on. They turn on the switches, make little beeping noises so you know that it's on and there's continuity and everything's connected. But essentially, you light the motor from half a mile away. There's a guy with a little control box that has wires running out to the pad. He says 3, 2, 1, go, pushes the button. It lights, hopefully, and then goes up to what's called apogee. That is the highest point in the flight. And then the drogue chute comes out. So drogue chute is a little tiny chute. For this one, it was about 3 feet in diameter. And basically, these altimeters read the pressure and read the acceleration. And they say, okay, we go up to the top, acceleration goes to 0-ish. It's going positive, 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 and then negative acceleration down towards the ground. So it knows, oh, it's time to release the drogue chute. So it lights one of these ends. These are my 3D printed parts. These are charge wells. So you put gunpowder in the charge well, put an E-match like this in the charge well, and then the 9 volts powered altimeters send a little pulse that ignites the E-match and ejects the parachute. Then it falls for quite a bit of time, and then at a specified altitude, that's where the barometer comes in, it releases the main chute, which is on the other end of this. The main chute is a lot bigger, and you do the drogue chute first, so you get kind of a steeper profile. As you can see here, it falls down a little bit faster. You don't want it floating away. I've seen rockets that deploy their big chute at apogee and go 10 miles east with the wind, and it's not very fun. So you deploy the main chute at about 1,500 to 1,000 feet above ground level, and then you have a shallower grade decline as it falls towards the ground, and that slows it down enough so it kisses the ground at a nice 13 miles an hour, 20 feet per second, give or take. It sounds really loud, but it's actually quite soft for a rocket. But yeah, that's kind of the timeline of how it goes. We'll just, there we go. Can't fall if it's on the ground. But I've got a video. We'll see if this works. Oh, shoot.
Nice job.
Yeah, so we'll try this. This is my level 3 rocket, so Malice Bene. This is her second launch, and maybe it will go.
What does the name stand for?
Yeah, so all of my rockets have Latin names. Ad Caelum is to the heavens. That was my first ever rocket I ever did. The second one is unpainted. That one's Ex Orumne, out of the hardships. And then Malice Bene means bad good, because it is a gorgeous rocket. It's fantastic, it's wonderful, but it was a pain in the tushy to build. So we'll see. Here, hold on just a second. Oh, well. Okay, it's filming. Oh, mama. That took way too long.
Do we need need to twist it any, or is it?
Are you comfortable with the body tube laying on those things, or do we need to twist it some?
No,
we can
it's
do it while
okay.
it's up there, too.
It's sitting on the.
It's not the body tube. It's the.
It's sitting on the butt of the rocket.
Yeah.
Oops. Need to get that chunk of Milo out of there or something. Or maybe move the pad. There. Or, there we go.
Can't really change much now.
So we on the electronics first.
Yes, sir.
That's a pretty good guess.
Give anxiety. Bingo. I think it does take longer every time. Oh,
It feels like it.
What's that?
I don't know why they make it so long.
It comes in handy.
You got it on your elbow even.
Yeah, oh, fuck it.
Bob, I'm gonna keep that on the video. Post it on the Triple E Facebook.
I'm sorry to hear you didn't pass your third attempt.
Do not. Do not.
I think you got the break.
I'll cry right now. I'll do it. You think I won't, but I will. Okay. Alright.
I haven't seen this video on my Facebook. Because I can get this. I know people in Tripoli to get that thing overturned.
After everything I've been through.
Green light.
Alright. Yes, please. Trey and Thomas, y'all can be in it too if you want.
So, y'all moment.
And can I get a picture with you two?
Sure.
That's alright. Please.
Come on, Mr. Bailey.
I'd be happy to.
Thank you.
Got the gut sucked in.
Thank you, Thomas.
Give a kiss. Okay.
Fly straight, fly true. Parachutes deploy, I swear.
Morgan Lyons, pad 67 in 5, 4, 3, 2, 1. Good luck. We're going to recycle and try that again.
I saw a puff of smoke whenever it lit.
There you go. I'll teach you the lesson.
Oh, yeah. Okay. Alright.
Give her another checky checky.
agree Morgan's rocket's gonna fly and recover properly? Okay, that's an affirmative. Let's do it. Going up in 5, 4, 3, 2, 1, launch. Smoke. That's the third Pyrex for the win today.
I see it. I see two pieces.
Thank you. Gerald, we got an event at the top. We got a report of a parachute out.
I don't see. Yeah. I saw it. They're both in the same I think it's in one piece.
It's in one piece.
Well, as in, it's connected. Yeah. It's two separate bodies.
It's held together. That's good.
What's your main
1100.
hang on and stuff while I follow up?
Sorry, with the blue, white rocket with the blue drone.
Anybody got visual on it?
No, no, I know.
Still nothing in the air.
I've got an idea. I think I might have to
We didn't see it out south, but are you talking about drogue event or main event? We only saw drogue event.
As I'm checking it back here.
Hey, we got it.
Good parachute.
Undershoot.
There it is. There it is. All stretched out.
Uh-oh. Just kidding, Morgan.
That's all stretched out.
Nice job. Nice job.
Well, it's
Just coming over between the two.
Just
Just to the
underneath
right of
that
the rail, right at the top.
white. Big breath.
What the heck? No signal. We're not gonna get it for a second, but we know what direction to go. Good.
and it's not as spinny, and it kisses the ground at a nice 13 miles an hour. So, radios. That's all rockets. Radios. You're here for rockets and radios. What problems do radios solve? So, radios are very, very important in rocketry because you want to be able to do a couple things with your rockets. You can just launch them willy-nilly, hope they go where you want them to go, hope you find them, but that's not really the best way to do things, especially with your, when you're dealing with high-powered energetics, such as these motors. So, safety is a very, very big thing in rocketry. They work with the rocketry clubs, work with the Alcohol, Tobacco, and Firearms organization in the government to make sure everything is done properly. Yeah, bow fangs are very helpful. I know they're frowned upon, but they're cheap and they're disposable, and they're wonderful. And I have my brand new one on my hip. So arm rockets, they can be really, really far away. As you can see on that picture on the far right, I'm at the flight line. You can see kind of the orange tape at the bottom. I'm at the flight line, and those poles out there are about half a mile, 3/4 of a mile away. Those are the rocket launch stands. So if you need to talk to people back at the base station, you need radios. There's no cell service usually at any of these launch places because you're in the farmlands of Kansas and they don't have cell towers out there. You also have to be able to communicate really quickly if something goes wrong. Up there, at the very top, that rocket is coming in what is called ballistically. It's uncontrolled and burning up, and it can land in what we call a lawn dart into the ground, like you see at the bottom of the photo. Those are very difficult to get out of the ground and not very fun. That's what happens if your rocket doesn't do things that it's supposed to do and the safety checks fail. So safety is very, very important in rocketry. So if something happens at the pad or something happens at base station and you need to talk to each other, radios are very, very important for that. Data acquisition is also incredibly important, at least to me it is. You can get flight computer data via radio, and I'll talk about a couple different methods in a second, but things like voltage, acceleration, and altitude are very, very important. So that's what that graph over there is showing. The blue line is the altitude, the red line is the acceleration, and the green is the battery voltage. Just so you know, if you have a brownout, if you have a blackout, you can look while the flight is happening. You can also track via GPS or some other system. There are some modules that I use that actually will help plot it on a map for you. So you can see it launches at the red dot, it goes up, 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 and then it deploys the main chute at the blue dot, lands at the black dot, and that's where it ends up, and it makes it a lot easier to find than...
So because of the lines on the ground, you know that that's just over a mile away?
Yes, yes, because of the mile square plots of land. But yeah, you can get coordinates, and then GPS will actually measure altitude as well. And that's pretty helpful if you're trying to know how high it's going in the moment. Ease of recovery, like I said, is very important. Recovery is probably the hardest part of the launch day activities because it's usually hot, it's usually humid or just gross outside, not fun to be outside, and you need to be able to communicate to the folks at the base station back home, just hanging out until, I guess, something goes wrong. But if you can't find the rocket, if someone has emergency, heat stroke, or needs water, radios help you get that communication. And ease of recovery, like I mentioned, direction finding is one way you can find your rockets, like a fox hunt for rocketry. You'd be surprised how difficult it is to find these rockets in a flat field. If the parachute is not blowing up in the wind and the Milo or the soybeans is up at your waist, it is very difficult to find. I've had that happen a couple different times. But yeah, you can get, like I mentioned, the GPS coordinates or talk back to the folks at your base camp, because usually whenever you launch a rocket, it's not just you by yourself. You've got friends that come along and help, and it's just good to have that back and forth. So contingency plans and whatnot. So you can do rocketry without a ham license. You can do button trackers like those little guys with the folded dipole tracking gun. That's just a 1 1/4 meter band. It's directional tracking. It's like a fox hunt. You can also do basic altimeters like these two at the bottom. Those are commercial, off-the-shelf, commercially available altimeters. Pardon me, they don't have any GPS tracking. They don't have any relay back to ground or back to base station or anything like that. They just sit in the rocket, collect data, and then once you find your rocket, they spit it back out onto your computer or whatever you're taking your data on. Usually they have an accelerometer and a barometer, especially if you're doing dual deploy. They also act as checks for each other, that accelerometer and barometer. There are some more advanced trackers that you can do without a ham license. You can use them in the 900 megahertz band using protocols like LoRa, CSS, or FSK. These look like that little guy with the rubber ducky antenna. You just throw it in the rocket in your electronics bay, and you'll get a GPS signal using, I think it's a HOPE RF module. It'll send you data. I use a 900 megahertz vertical just strapped to the side of my tent, plug it into my computer via the dongle, and I can track that rocket. I've only used it a couple of times, but I've gotten it pretty close within 100 feet, which actually is relatively small in the grand scheme of things. I probably could have gotten closer, but my back was to a metal trailer and the rocket fell behind me. So I lost signal a couple 100 feet above the ground because it fell behind the trailer. But you can still do radios without a ham license, but I think it gets a little bit cooler when you do it with a ham license. There is one really commercial, off-the-shelf, available brand of altimeters that require a ham license. It's the Alta Spectrum brand of products. Those were produced by Keith Packard and B. Del Garby. If y'all know those guys, they're big in ARDC. But they invented the Telemetrum, which is that tracker right there. It's one of the more high-end trackers. It's quite expensive for what it is, but it does a really good job. It uses 70 centimeters and sends you data via APRS, so you can get that immediate data. Your computer reads it out in a very scary robot voice that sounds like the Terminator, but it works and lets people know how high your rocket is and if the events happen in order. You can also use directional tracking. It acts as a beacon as well. So you can also build your own. It's very exciting when you build your own. So right now I am developing with my lovely assistant, Thomas, KX0STL, back there. He is the brains of the operation, but I'm a systems engineer, so I write the requirements. He's the electrical engineer. He actually executes the project. But that is a demo board that he created using some of my requirements for tracking. So it's going to act kind of like the button trackers, but be a little bit more advanced. We'd like it to be programmable CW, so you can chirp out your call sign and say, this is mine. And you can also adjust the frequency a little bit. It'll only be 1/2 watt. You don't want it to be too powerful because like a fox hunt, if it's too powerful, then you start running in a circle and you can't find it because it's too strong and it's coming from everywhere. If it's too low, then you can't find it at all. So 1/2 watt's pretty good. Power it with a coin cell watch battery and use it a small form factor. Those are regular SMA connectors, so if you can imagine, it's a little tiny thing, but we want to be able to use it in small rockets, maybe even this size, just so you can track it if it goes way off course or anything like that. It'll just use a simple wire whip, nothing too crazy, maybe a rubber ducky if we're feeling really exciting, but it's fun to try and build your own and figure all of that out. Thomas actually designed that board himself, did the layout, and he's got his little logo in the bottom. So hopefully we'll start selling these in the next couple of years, maybe a year or so, because those button trackers I showed earlier are no longer being produced and are going for $150 for a 1-beep, single cell, stupid button tracker. So we want to sell these for a lot cheaper and maybe provide a service to our fellow Rocketeers. So, oh, skipped a slide. What else can you do? You can make your own. So rocketry is kind of a customizable hobby. It's very similar to ham radio. You've got the 3 license classes. You can build rockets, you can do electronics, you can do really whatever you want with it. Make it your own. You can build from a kit, you can build from scratch. You can do the same thing with the radios for the rockets. Amateur rocketry is really lacking in this radio RF technology because it's a bunch of aerospace and mechanical engineers or just old guys that grew up building Estes rockets that don't know anything about radios. We need hams to actually change that to help saturate the market with these different kinds of radio beacons, radio trackers, to A, get more people into ham radio, because that's kind of everyone's goal, right? And B, to just make it easier to find your stuff. Like, we have all of this great technology, but there's people still losing their rockets out there, spending hundreds of dollars to build this thing, and then it's just gone. Like, it's not worth it. Common bands usually use 2 meters, 1 1/4, 70 centimeters, and 33 centimeters. But you can really do whatever you want. We've talked about sticking a transmitter in my rocket and trailing a wire out the end, seeing if we can make some contacts on the HF bands. We've also talked about putting a little Raspberry Pi Baofeng repeater, seeing if we can bounce contacts off the rocket while it is in flight. But it's up to you to figure it out. It's a fun problem. Ham radio is a lot about problem solving, figuring out challenges, seeing what you can do, pushing the limits of technology, and the rocketry community needs all of you. So if you're interested and you want to get involved in rocketry, there is a very large rocketry club here in St. Louis, actually. Y'all are very lucky. You've got quite a wonderful club. You can sign up for, or you can check them out at the website on that right-hand QR code, and then just check out the Tripoli Rocketry Association. That's the national club that I'm a part of. They've got maps with all the prefectures everywhere. So St. Louis, they launch at Butter Park in Valley Park, I think. And then that's for the low power little guys like this one. And then they do high powered like this one or those two out up north in Ellsbury. They've got a piece of land and a flight waiver out there if you want to do bigger stuff. But they're a really cool group of guys. I've actually launched a couple things. We've been at the same launches. They always do some crazy, incredible, giant launch. A couple years ago, a long time ago actually, they made a Marvin the Martian rocket, like weird shaped, and it had a bowling ball on top for the little circle, and it was true to proportion, and it was huge, and it went up, arced over, and then went down, and it worked. That's all they anticipated it to do, and it was quite the spectacle. But they've done a whole bunch of cool projects. If you want to just do radios and do electronics, they're always looking for people to do that. Or if you want to get into rockets, they're the folks to reach out to in this area. They're the closest one for probably at least 100 miles, but there are rocketry clubs everywhere. You can look up at the Tripoli Rocketry Association website, and that will give you information on the prefectures wherever you may be. So, fun time. Questions? Yeah, what's up?
For flight, controlled flight space, is there only certain launch places that you can launch that's already pre-approved, so you don't have to worry about any aircraft being at altitude in that area? And then the second part was, on the larger rockets, what is the approximate consumable cost? Mainly, a lot of it's reusable if there's no accident, right? It's the fuel.
Sure.
Mainly, so what an idea of what a launch would cost
Okay, so the launch sites are usually done by a club, by a prefecture, with the Tripoli Rocketry Association or the National Association of Rocketry. I launch out in Kansas, but that's mainly because they have a higher flight waiver. It really just depends on where you are. I think the Ellsbury location here only goes up to about 6,000 feet above ground level, which I could launch these 2 rockets, but I couldn't launch this one. So I go out to Kansas where the waiver is 55,000 feet, or 50,000 feet. The clubs actually talk with the FAA. They usually have something worked out where they launch the first Saturday of every month or whatever, get together, do a launch. And you have a waiver set from 9 a.m. to 4 p.m. You can launch rockets. There's a temporary flight restriction around that, where planes can't fly a certain radius around the launch site, so nothing bad happens. And you don't get a NORAD called on you or anything like that. But the clubs usually handle that for you, so you usually just show up, pay the launch fee, and go. Some clubs don't have a launch fee. It really just depends on where you launch. So the consumable cost varies greatly with what you're doing, and it grows exponentially with the size of your rocket. So this one right here, this little guy, it's about $50 to launch. The price of motors has gone up in recent years, partially due to COVID, but this one, I just buy a motor, stick it in, launch it, and it's about $45, $50 for a motor. The big one, motors can cost up to like $450. It gets really steep really fast, so I only launch about once or twice a year because I am a broke college student. But building is definitely the highest cost, but if you do it right, you can reuse it over and over and over again. So does that answer it?
Yeah, you use solid rocket, right?
Yes, solid rocket fuel.
You put it in there.
You just throw it in there, yeah. Nope.
So is there, is it something where if I don't buy that, it has to be ground transportation and labor?
Yes, so whenever you buy it, I usually try to like pick my stuff up at the launch site if that's available, because hazmat shipping is really expensive. Sometimes it's more expensive to have it shipped than it is to buy the motor itself. So I usually try to pick it up at the launch because those vendors are allowed to transport it or whatever in their trailers. But you do have to get hazmat shipping for these motors just because it's a high-powered energetic. So, yeah. What's up?
Two things. Do you do a weight and balance on these?
Yes. So I designed these in a program called Open Rocket. It's an open source software that was done by a PhD student in Sweden a couple of years ago for his thesis. But basically, you're looking for a couple different numbers. You're looking for the center of pressure, which it calculates for you, which is pretty nice. But that's the center of aerodynamic pressure on the rocket. It's usually about a third of the way from the bottom on average, but that if you were to minimize all the pressures to 1 point, 1 force vector, that's where it would be. And then there's also the center of mass, which depends on how heavy your rocket is. You can find that experimentally by like putting a strap underneath the rocket, holding it, seeing if it tips. So you are looking for a stability caliber. It's kind of a weird unit, but it's found by taking the distance between the center of pressure and center of mass, subtracting them, dividing them by the circumference or the diameter of the rocket, and it gives you a number. You want it to be between 1 and 2 realistically, and that number tells you if your rocket's gonna cant into the wind, if it blows, or if it's gonna like spiral or flip. That's really what you're looking, and the software I use does it all for me because I don't want to do all those calculations by hand. But you can find it experimentally, or you can find it with math if you really wanted to, but the software is kind of the way to go.
Okay, the second thing was, I thought, I don't know if I wasn't there a problem a little while, just a little after 9/11, that they were not selling rocket motors?
Yes, there was a big thing in the 2000s with the,
I mean, even those little ones.
yeah, it was a big deal after 9/11 with the ATF and the rocketry clubs. But they have come to an agreement and they've got safety codes in place, and it's very regulated to get a motor. You have to prove to the vendor, like send them your number with the club that you're with. You get a little number that designates your license, and you have to send that in so they can make sure you are qualified and you know what you're doing. You aren't going to hurt someone.
Just go to
So,
Schaefer's and buy
no, not for things this big. For the little ones, you can buy them at a hobby store, but the big ones, you have to have the license to be able to
But
purchase.
At one time, you could buy the bigger ones.
Yes, I think so, yes.
At least up to a D. Because Estes makes those are straight off the shelf.
Yes, Cliff.
Do you know Craig K4LSU?
Someone asked me that earlier.
We were talking
Yeah,
about it earlier. She knows of him, but not.
yes. I don't know him personally, but
I'd love to meet you, and you would enjoy meeting him.
yeah, I would love to. I'll shoot him an email.
Rocket lady, he's rocket man.
Yes.
K4LSU.
Roger, Roger. What's up?
Is there any steering or guidance system in these, or you just load it and just go?
So it gets kind of squirrely whenever you start putting guidance and like control surfaces on the rocket, because that is usually called a missile, the M word. We don't like it. So most rocket people steer away from that controlled aspect of it. Yes. So you do simulations, you do the math, you use the wind and calculate on the launch site where it's going to go, more or less. But once you get into those control surfaces, and it's pretty hard to do on this scale. It's kind of difficult. There's some YouTube people that have tried to do like control surfaces on the fins and thrust vectoring and stuff like that. But on this scale, especially with solid rockets, you can't throttle, you can't do anything like that. So it's usually fins or canards. So most people just steer clear of that, and if the wind is too windy, you don't launch. But you usually just light it and you go. And it does have to get checked out by a range safety officer. There are lots of safety checks in place. I can't stress that enough. But you have to prove to them that you know what you're doing and you designed it well. And once again, that goes along with having that license class. You can't do certain classes of motors if you don't have the proper licensing. Yes?
On your large one, what's your total flight time?
It's about 4.5 minutes from launch to land. Yes?
How do you keep the Druger from being a sail after it's deployed and your main comes out?
Yeah, so the drogue really just kind of hangs out. It doesn't, it's so small in these size rockets, it doesn't really catch. It's half the size of the big one, so it just kind of floats. And really, I'm not going to be launching if I'm worried about it going miles and miles away. The farthest I've had a rocket land away from me at the flight line is about 2 miles. But you can usually narrow it down to whichever farm square you're in. So, any other questions? Yes? The Killer Queen Remastered was 13.5 feet tall, 13 or 14 feet tall. So a lot taller than me. A lot taller than you. Yeah, is there another?
What is the body made out of?
Yeah, so you can make it out of a couple different materials. I prefer to use fiberglass because it's light, it's pretty cheap. Carbon fiber you get more expensive, and then it's also not RF transparent. So that is something you have to be conscious of. Carbon fiber is usually used for higher and faster going rockets, and then you'll use like a fiberglass nose cone. But it's filament wound and then sanded down really, really smooth. The fins on this red one and the black and white one are plywood sandwiched between carbon fiber. So I do use carbon fiber on the rockets. I do a flat layup, saturate it with epoxy, and then vacuum it so it gets all the bubbles out, and then sand the heck out of it so it smooths out. But most of it is G12 fiberglass or filament wound fiberglass.
So it's all custom made.
Yes. And there are suppliers that make this, so I didn't have to wind this myself. I don't really want to wind it myself. I don't have a lathe at home that I can use to sand it. So there are rocketry vendors that sell these tubes already pre-sanded and pre-cut. So, yes?
So about how many hours would you say you put into designing and putting together one of these?
Oh gosh, okay.
Ballpark.
I don't even know if I could. So this black and white one took me 8 months to do, from like first design to launch. That was also while being a full-time student, but I did put in a couple 40-hour work weeks trying to get this thing done. So 1,000 hours, maybe, at least. A lot. Like it's not just, the little ones you can build in a couple hours, you can build in an hour. The big ones, they require a lot more planning. And even before launching, you have to make sure you have everything together. You have to make sure all of your stuff is within spec, all of your cord works. The rockets are actually held together by Kevlar, Kevlar cord. So this is called shock cord because it absorbs the shock whenever the parachutes come out. So this is a little bit overbuilt, but this is what I use for the black and white. It's a tubular Kevlar. It's flame resistant and to a degree, and is very hard to break. I've actually broken some scissors trying to cut this, but there's a lot of work that goes in, even if you're just launching one that you've already launched before. Yes, Ron?
Do amateur rockets implement multiple stages, and if so, how many stages do you ever see?
So the highest, the largest amount of stages I've seen was by, oh gosh, what was his name? Fred. I don't remember his last name, but his first name's Fred. He is known as the god of staging. He has done a 5-stage rocket. I don't know if he's done it successfully yet, but he's sure as hell tried. But he's launched a 5-stage rocket. So you can definitely do staging with these. It gets a little more complicated. You have to make sure your logic and your altimeters is correct. So for staging, your altimeters have to have a gyroscope or something to make sure it's going up and not canted over, because you don't really want to light it when it's parallel to the ground. That's also when it becomes a ballistic missile. But yeah, staging is something that you can do. I don't have very much experience with staging myself. I want to do it eventually, but I just haven't had the time, and I just launched these 3 mostly. So, yes.
On Killer Bee,
Mhm.
it looked like you had another rocket on the side of it.
Yes. It was just another rocket in the picture. So that,
So it wasn't actually on the side of
No,
the
no.
Killer Bee. Okay.
yeah, so I'll go back to my projects if it will, well, dagnabbit. Yeah, so,
Right there.
yeah, that's just another nose cone. We actually made a bunch of those. That was for a contract when I was on the rocket design team at the university. We had a contract with an aerospace company, so they would give us a black box payload and say launch it this high, this fast, this much acceleration, and we'd put it in a rocket. They don't tell us what it was, but we'd put it in a rocket, test it for them. We'd give it back to them. They'd give us a fair amount of money, so cheap labor for them, experience for us, but we made several rockets of that design.
And money for the next launch.
Yes. Yes.
The top right picture,
Mhm.
are you checking the center of mass?
Yes, that's what I'm doing with Malus Bene is I'm using my shot cord actually to make sure I know exactly where the center of mass is, because when you're doing a certification flight, you have to actually mark that for the range safety officer so they can eyeball it and say, yeah, you're pretty good. Yes.
So you're away from where the launch is at.
Mhm.
I was wondering what the sound level would be at. if
Yeah.
you're at the launch site.
It sounds like a jet plane going by. Like, it's not as loud as a jet plane, but it's kind of like a kind of noise as it goes up. I get asked about like shock waves. Usually you don't get a shock that you can hear because unlike a plane, it's parallel to the ground. It has to go off the rod, off the launch rail really, really fast to be able to hear that shock. So it just kind of sounds like a pew. And if you look at my video on my QRZ that has sound, you can hear it. But you can feel it in your chest whenever it launches. It's no small thing. The first launch I went to, I kind of got freaked out the first couple times because if you're not paying attention, it's very, very loud. So, yes.
So, at the apogee point, where you push out the drone with the golf ball, you said you used gunpowder as the
Yes.
launch. Black powder or smokeless?
Black powder.
What I suspected.
Yeah, just plain black powder. It's been really hard to get since the GoEx plant exploded, but it's you just plain black powder and the.
Ask if it's triple F or double F. But.
I couldn't tell you, Chief. I'm gonna be honest with you. I haven't bought black powder in a long time. I've just kind of siphoned off my friends. So, you know, yes.
Do you actually launch it, as far as pushing the button to set it, or is somebody else doing that?
So I have not ever gotten to launch one of my big ones by pushing the button. Usually there's a range safety officer because they have to do a couple different checks before they launch. They have to make sure no one's out in the field because people go out to rack their rockets and get things set up. You want to make sure no one's out there. You want to make sure the sky's clear. And the flyer is ready to go. So usually it's just.
Do you have radio silence when the wire's connected?
Yes. Yeah.
I would think so.
So usually it's just one guy. His name's Terry. He's a cool guy. But he pushes the button and it launches. So, any more? Yes.
Do you play with the nozzle size for speed and burn
So you can if you build your own motors. So that's something I didn't even get into. People build their own motors, like not just like sugar motors. They do legitimate rocket motors. And you can play with the nozzle size a little bit depending on your propellant and the way it burns. But with what I buy, it comes with a nozzle, and I don't mess with it because it is usually a phenolic nozzle, phenolic composite with a graphite throat. So the smallest point is graphite, and it ablates as the fuel comes through. But yeah, I don't really screw with that. I don't want to do the math. I do the math in school all the time. So, yes.
So what is the voltage of the battery that you use when you press the button to ignite?
I honestly don't know. It's not very much, I would imagine. So like these little igniters, you can ignite with a 9 volt, but I don't use this size for the big rockets. I'm sure it's like a 12 volt something or other, car battery, something like that, but it doesn't take a whole lot to ignite it. Well, let me rephrase. The motors are very inert. It takes a lot to ignite the motors, but the igniters themselves don't take a whole lot. They're not gonna like blow up in your hand or like with a whole bunch of like static electricity, but it's not a lot of current that it takes.
Aren't the Estes rockets only 3 volts, 2 AA's?
Yep. Yeah. Yes.
The large rocket,
Mhm.
did you say it was a Class O motor?
Yes, this yellow one and then the one with the blue flame, that's I think it was an O-3400. So that's O-class is the impulse of the rocket, which is a weird measurement of Newton seconds. That's kind of how powerful it is. And then the average thrust is 3,400 newtons, so 3,400 newtons over the 10-second, 20-second burn time.
For the large one, the largest one there,
Mm-hmm.
I'm trying to recall, did you say it was a 6-inch radius diameter?
So the yellow one, the rocket.
On the table.
Oh, this one. Sorry. So this one, the outer diameter is 5 inches. So it's 5 inches outer diameter, and then it uses a 75 millimeter diameter propellant case. So it's 3 inches. If I wanted to, I could take this and stick it in this rocket and have it be what's called a minimum diameter. It's basically a motor with fins. Goes really high and really fast. But yeah, this is a 3-inch, 75 millimeter motor case that I use for the big one.
Total weight, what was the width or height, I guess, on this launch tip to
For this one?
Yeah, and also what's the total launch rate?
Yeah, so the black and white one, it's about 9.5 feet. I don't remember the exact length. The wet weight with the motor and the casing and all of it, it's about 30 pounds. Dry, it's about 20. So the casing and the propellant adds about 10 pounds to it. But it's, yes, yes, it is. It better be. But yeah. Yes.
You know, like it was the way things go now, so much safety to it.
Mm-hmm.
Going back, I used to do drag racing up in New York back in the 70s,
Mm-hmm.
you know, late 70s, 78, 79. And we used to stand maybe 40 or 50 feet away from rocket cars with rocket motors. And we would stand on the sideline, and a rocket car would be over there, and that thing would light up and make that big sound, that whooshing sound, and your whole body would vibrate.
Oh, yeah.
And all us crazy people are standing right on the side of a rocket car, ready to shoot down the thing at about 500 miles an hour.
Yeah.
But now it's so much safety.
Yes. Yeah. It's a big deal. It's sad, but accidents have happened, and all of it is to prevent more accidents and prevent people from getting hurt. Yes, Ron?
I have a question on the topic of radios.
Mm-hmm.
What is the popularity of CW beacons over like LoRa GPS transmission? Why one versus the other? GPS seems like an obvious.
Yeah. So price difference is a big factor. The LoRa beacons can get a little expensive, but if you find a cheap, like a people use falconer beacons that you like tie on a bird, or like dog trackers, they'll just throw those in the rocket, and that's a lot easier to track. You can just use like a small radio and an antenna, a Yagi or something like that. But like the LoRa, you need a laptop, you need something to receive it, you need the dongle, it's a little bit more involved. So, anyone else? Well, thank you all so much. I really do appreciate your time. It's been wonderful.